Hello, so I'm going to take you through a circle theorem question. Now, this was on a WJEC intermediate paper, and as we can see, it is, as I just said, a circle theorem question. Now, these tend to be at the back of the paper because they are very much a grade B question, although, as I've always said about back of the paper questions, there are things within these questions that even if you didn't fully understand circle theorems, you would be able to get something from them. So let's just take a general look rather than just me going in straight and saying the answer to this is this, is just look at what we've got. We've got a circle. Whenever you see O, unless it tells you in the question, generally O is the centre. So then you've got two lines going from the centre to the outside of the circle. So remember, the outside of the circle is what we call the circumference, part of the circumference. It's like the perimeter of the circle, if you like. Then you've got the line, the length from the centre of the circle to the outside is the radius. So as you're doing these here, just do a quick recce of what is on there. So what does that tell you about the length of that line there and that line there? Well, they're both the radius, so they're the same. And you know that notation that you see? In fact, I'll put the line there. Well, that is meant to be a line just to say it's the same length. Okay, just something to bear in mind. So therefore, we know that that is 4 centimetres as well. So whenever we know something on a diagram, put it on there. Because quite often, the thinking style that's required in exams with maths is very much well, not just the exam, is you have to question what you can see and what you can also work out. What do I also know about what's in front of me? And, you've just got to practice that or get taught it. And obviously that's why I'm doing this now. Now, we've also got, there is a particular shape here, isn't there? It's a 4-sided shape. What is that when you've got 2 sides here the same length? Looks kind of like a kite, doesn't it? Now, we know it's a kite because there is a circle theorem that says, first of all, the tangent to a circle, which is this line here. I'm just going to highlight this. I've got a lesson. Literally, my student's going to turn up at any point, so I might finish it by the time she thinks. It's actually the student that I'm recording this for, but I'm recording it before she gets here because then at least it's done. So these lines here are what we call a tangent to the circle because it's a straight line that touches the circle at one point. Okay. In fact, I'm going to carry that on. There's something else you can do on your diagrams as well. Sometimes, it just helps that, like, okay, well, if I was to just carry that line up there, what would it look like? Yeah, doesn't change anything in your diagram at all. Now, there are a couple of circle theorems that tell us the radius meets the tangent to the circle at that point. So in other words, when it touches the tangent to the circle at that point A, it meets it at a right angle. So therefore, that is a right angle. Is there anywhere else where a radius of a circle meets another tangent? There. So that particular straight line touches the circle at B, and you've also got the radius going out from the centre that touches it. So therefore, and it says this in the wording of the question, it says the radius meets the, where it tells you that that line there meets the tangent at point B. So in other words, you're like, right, okay, circle theorem, that's a right angle, that's a right angle. Now, there is another circle theorem. So in other words, think of circle theorem as it's just a load of rules to do with circles. All right, rules that apply to lines linked to circles. That's it really. So another one is that when you go from, if you've got 2 tangents going from a circle, they will meet at a point. They will create 2 lines that are the same length. Okay, so if you've got a tangent from here and a tangent from there, and they go out wherever they meet, that is going to be the same length. So, I'm sorry, I just heard my daughter talking. So A to P is the same as length as B to P. So therefore, the first question is asking you, what's the length of PA? Well, the length of PA because of the way the circle theorem works, the length tells me that that is the same length as that. So therefore, PA is equal to 12 centimetres. Okay, and the reason is the tangents meet at a point and the distance from those two is exactly the same. Okay, the wording of it might be slightly different, just but it's one of those I couldn't just think off the top of my head. But basically, they are the two tangents from a circle meet at a point and they are the same length. Okay, right then. So what else have we got here? What's the sum when it says PAO with that little like roofy thing over the top? That basically means angle from P to A to O. So what I would do is get a highlighter pen, which I have loads, but well, here we go. Couldn't find there. So P, let's go from P to A and up to O. There we go. Well, already mentioned that, haven't I? Because remember I said earlier on that the radius, because this is a radius, and that is the tangent, and the radius meets the tangent at point A, that particular angle is a right angle. It's 90 degrees because the radius meets the tangent at a point, at a given point, at a right angle. Okay? Oh, he's cute. Sorry, Caris, my daughter, was just showing me a picture of the cat who's stood on top of the conservatory in her bedroom, looking to go into her bedroom window. Bless her. Right then, so the last part now, I think I've got about 5 minutes before my student gets here. So the area of, not very helpful, dear daughter. So that's why I was in my cat. She thought, oh, Stevie wants to come and join in. Go and do the work I've asked you to do. Right, so area of PAOB. Now, PAOB. Now, have you learned how to find the area of a kite? Now, you can tell it's definitely a kite because you've got two sides that they're the same length. Caris, can you go out, please, so I can just get this done? And then they're the same length as well. And notice how I've got two lines here to show that they're the same length, but they're a different length to these two here. So that's why you sometimes see them with one line or two lines. Now, you have not learned, there's no standard formula necessarily that you've learned at intermediate level for area of a kite. But what you have got is two shapes that are exactly the same. You have got, and I'm going to use this here now, you've actually got two triangles. You've got two right angle triangles, in fact. Okay, so you've got, I'm just going to turn this round. And in fact, as I'm doing that, that's another little tip for you. So when you're in an exam or, or practicing, doing a task for homework or what have you, remember your piece of paper isn't fixed. Even if it's part of a book, please don't rip your paper out of your school books. But you can rotate it. Yeah, sometimes it gives you a different perspective. So just another one of my hundreds of tips that I give out to people. Oops, hang on a minute. I've not, I need to put that one there as well because that's, see, there's two triangles there. Right, so we have two triangles. So if we were to find the area of that triangle, it's exactly the same as that triangle, so we just multiply it by 2. So how do we find the area of the triangle? Well, if we were to work out the area of PAO, well, that is half, and this is where you just have to know your formulas. There's certain rules that you do need to learn in maths, and that is half times the base, which was 12 centimetres, multiplied by the height. Now that height in this particular case is 4. And just remember that height is not necessarily from just literally from there to there. It's the one that creates a right angle with the base. It's what we call the perpendicular height. So whenever you've got, especially a right angle triangle, you can see that that's the height of the triangle because it makes a right angle with the base. So that's the number we use. So with these, again, non-calculator paper, you can switch the order of these if you want to. Because if you did a half times 12 times 4, you'd get exactly the same answer as a half times 4 times 12. Doesn't matter. So what I would do is I would do a half times 12. A half of 12 is 6. And then you multiply that answer by 4, which is 24. Now the units in this question were centimetres, so the area will be 24 centimetres squared. Now remember, that's only the area for this part. And then, so therefore, this one is the same as well. And even if you hadn't spotted it, what you can do is just say, well, let's just work out the area of this one. So the height is 4 centimetres, the base is 12 centimetres, so a half times the base times the height is the same. So therefore, the area of PAOB, the quadrilateral P to A to O to B, is equal to 24 plus 24, which is equal to 48 centimetres squared. And as I always say, I don't think I've done it in this video on this one particularly, but always, always, always show your steps if you're working. Because if you'd sort of just done that 24 and then you're like, okay, I need to multiply it by 2, but I forget, and then you write the answer down wrong, you'll get no marks for that part. Whereas notice what I've done. I've said the area of the actual quadrilateral is the 24 plus the 24. Or I could have done 2 lots of 24. You know, either of those, because at least if I didn't get this answer right and I made an avoidable error, which again happens, at least I've got something the examiner can see that I knew I had to add. I knew there was 2 of them that I needed to add together. And if I did the adding slightly wrong, at least I've shown that I knew what the correct method was for doing that. And the maths, when you do, part of your maths qualification is not about the final answers. Yeah, they're great if you can solve the problems, but there's a lot of marks for things like accuracy, for method, for problem solving. There's just so much that goes into it. So you want to grab as many of them marks as you can. Okay, my student is probably just about to ring the doorbell, so I will leave. And the person I'm recording this for is about to turn up at my door. All right, take care. Thanks. Bye.